Okay, Assalamualaikum and hi everyone. So this is the next subtopic for chapter 5 on the power series. So in this subtopic, we are going to study the expansion for exponential, logarithm and trigonometric. Okay, alright. Okay, for the power series, okay, the way how we want to expand, for example, we want to expand ANXN, so we are using this formula A naught plus A1x, A2x naught, and so on until ANXN. Okay, and then but this one is for when x equal to 0, but when x equal to a, so a can be any number. So the way we expand, we change from x to x minus 1. Okay, right. First we try to do how to get the expansion or the power series for the exponential. Okay, so for the exponential, so this is the expansion equation. Okay, let's do how we get that one. Okay, so by using the power series, so we have exponent x equal to a naught plus a1x1 plus a2x2 plus a3x3 and so on. Okay, so for the first step, what you need to do, you need to differentiate. Okay, you need to differentiate until you cannot get dx. Okay, so you differentiate once, so differentiate exponent x, so you get exponent x equal to a1 plus 2 a2x plus 3a3x squared plus dot dot. Okay, and then differentiate again, so still we got exponent x 2 2a2 plus 6a3x plus blah blah, and then differentiate again, so you get 6a3 plus dot dot dot, and then you stop. Okay, for the next step, what you need to do, you substitute x equal to 0 to all this equation. Okay, for example, I put this one as the first equation, this is second equation, third equation, and this is the fourth equation. Okay, so when I substitute the value x equal to 0 into 1, so I will get exponent 0 equal to a naught, so a naught is equal to 1 because of exponent 0 equal to 1. Okay, and then substitute x equal to 0 to the second equation, so exponent 0 equal to a1, so a1 equal to 1. Okay, again substitute x equal to 0 into equation number 3, so you get exponent 0 equal to 2a2, therefore a2 is equal to 1 over 2. And last one, exponent 0 equal to 6a3, therefore a3 is equal to 1 over 6. Okay, so the value of a, you substitute into equation 1, so the main equation, so this is the main equation, so substitute, therefore the expansion for exponential, so you get a naught is equal to 1 plus a1, so a1 is 1, so equal to x plus 1 over 2x squared plus 1 over 6x cubed plus dot dot dot. Okay, so from this series, so we can see that, so it's become 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed plus blah blah blah. Okay, so this is the expansion equation for the exponential. Okay, so for those that forget about the exponential, so 3 factorial is equal to 1 times 2 times 3, so equal to 6. Okay, so for those that already forget about the factorial. Okay, so this is how we want to get the expansion for the exponential. Okay, so we move to the example 5.12. So given the exponential, the expansion for the exponential, so write down the first 5 terms of the expansion of the following function. Okay, so for A, so we have exponent x equal to 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed. So since they want first 5 term, so 1, 2, 3, 4, and then we have to add another term, so x4 plus blah blah blah. So 5 term, 1, 2, 3, 4, 5 term. Okay, and then they want exponent to x. Okay, exponent to x. So exponent to x, so all the x, this x, 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 so you have to change to 2x. So the answer will be 1 plus 2x plus 1 over 2 2x squared plus 1 over 6 2x cubed plus 1 over 4 factorial is equal to 16. So x4 plus dot dot dot. Okay, so equal to 1 plus 2x plus, so 2x squared equal to 4x squared, so 4x squared, so we get 2x squared plus, so 4 over 3x cubed plus, oh I'm sorry, this one is 2x. Okay, 2x, so 2 to the power of 4 equal to 16. Oh I'm sorry, 4 factorial. Okay, sorry, my mistake. 4 factorial is equal to 1 times 2 times 3 times 4, so equal to 24. 24, here is 24, so 2 to the power of 4 equal to 16, so 16 over 24. So we simplify by the multiplication of 8, so we get 2 over 3 x4 plus blah blah blah. So this is the answer. Okay, so this is how we want to expand. Okay, B, how about B? So B, exponent x minus 1. Okay, so you can, what you can do, so exponent x minus 1 equal to exponent x times with exponent negative 1. Okay, exponent negative 1. So exponent negative 1 equal to 1 over exponent and then times with exponent x. So expansion for exponent x equal to 1 plus x plus 1 over 2 x squared plus 1 over 6 x cubed plus 1 over 24 x4 plus blah blah blah. Okay, so equal to 1 over exponent plus x over exponent plus x squared over 2 exponent plus x cubed over 6 exponent plus x to the power of 4 over 24 exponent plus blah blah blah. So this is the answer. Okay, so another step, so another technique you can do, So exponent x minus 1. So you need to change all the x to x minus 1. So 1 plus x. So x is equal to x minus 1 plus 1 over 2 factorial x minus 1 squared plus 1 over 3 factorial x minus 1 cube plus 1 over 4 factorial x minus 1 4 plus blah blah blah. Okay, so you expand, so you can expand this one, and then finally, so you have to check this one. This is my answer. So you will get 3 over 8 plus 1 over 3x plus 1 over 4x squared plus 1 over 24 x4 plus blah blah blah. Okay, and so both answer is accepted. If you want to check, so you can let's say you can let x equal to maybe any number, and then you substitute into this expansion, and also you substitute the same value of x here, and you can get it's not the same, but it's quite, the difference is not much different lah, you can get. Okay, alright. Okay, this one I want you to do on your own. Okay, so the answer will be 1 plus x minus 1 over 2 x squared minus 1 over 6 x cubed plus 5 over 24 x4 plus blah blah blah. So this is my answer, but you need to check. Okay. So for this question, what you need to do first, you need to find what is the expansion for the exponent negative x. So you need to change from x to the negative x, and then you expand this squared. After you expand this squared, and also you get this expansion, and then you expand this 2, and finally you will get this answer. But you still need to check, okay? Because this is my answer, you need to check. Okay, and then for the next one, the expansion for the logarithm. Okay, so for the logarithm, the problem here, we cannot get the expansion for the ln x. Okay, we cannot get the expansion for the ln x because of, if let's say x is equal to 0, so we will get undefined, because from the graph of ln, the graph start here. Okay, 1. So if x is equal to 0, so this is undefined. Therefore, if we want to get the expansion for the logarithm, so the function that we should start is ln 1 plus x, and for the minus, ln 1 minus x. Okay, so we cannot get the expansion for the ln x because here, this is the problem. Okay, so for ln, you have to remember, if we want to get the expansion for ln, so we should start the function as we should return the function as ln 1 plus x or ln 1 minus x. Okay, so this is the expansion. So let's try. Okay, so for ln, so ln 1 plus x equal to a naught plus a1 x1 plus a2 x2 plus a3 x3 plus blah blah blah. Okay, so next, what you need to do, you need to differentiate. So the same technique that how we did just now for the exponential here. So the same technique, you need to differentiate. Okay, so you differentiate ln 1 plus x, so you get 1 over 1 plus x, and don't forget to differentiate inside, but we still get 1. So the answer 1 over x equal to a1 plus 2a2 x plus 3a 3x squared plus blah blah blah. Okay, and then differentiate again. So differentiate again, so we get this one is similar to 1 plus x minus 1. So differentiate, so you get negative 1 over 1 plus x 2. Okay, so differentiate again, so you get the answer equal to 2a2 plus 6a 3x plus blah blah blah. Okay, and then differentiate again. So differentiate again, so you will get, so negative 2 bring to the front, so you get 2 over 1 plus x cube equal to 6a 3 plus blah blah blah. Okay, so this is the answer. So you have to stop, and then what you need to do, you substitute x equal to 0 to all this equation. So for the first one, you will get, so substitute x equal to 0, so you get 0 equal to a naught, so a naught equal to 0. And then for the second equation, so substitute 0, so you get 1 equal to a1. And for the third equation, so you get negative 1 equal to 2a2. So your a2 will be equal to negative 1 over 2. And then substitute 1, so you get 2. 2 over 2, 2 over 1, so 2 equal to 6a 3. So your a3 will be equal to 1 over 3. Okay, so for your expansion for ln 1 plus x, ln 1 plus x equal to a naught equal to 0. So x minus 1 over 2x squared plus 1 over 3x cubed plus blah blah blah. Okay, so we get this answer. So from this part, if we want to expand, so we can expand because we can see the the flow of equation. So plus, so minus, I think this one will be minus because of we can see plus minus plus, so this one will be minus 1 over 4 x4, and if you want to expand again, so minus plus 1 over 5 x5 and so on. Okay, so you can see the pattern lah from the when you doing the differentiate, and then you substitute the value of x equal to 0, so you can see the pattern. Okay, for the ln 1 minus x so ln 1 minus x, so what you need to do, all x you need to change to negative x. So I refer this one. Okay, so x, so becomes negative x minus 1 over 2 negative x squared plus 1 over 3 negative x cubed plus blah blah blah. Okay, so your answer will be negative x negative 1 over 2 x squared minus 1 over 3 x cubed. Okay, so from this equation, so we can see the pattern. So pattern will be negative 1 over 4 x4 minus 1 over 5 x5 plus blah blah blah. Okay, because we can see the pattern. Okay. Okay, now we do example 5.14. So write down the first 5 terms. Okay, first 5 terms of the expansion of the following. Okay, so A, ln 1 plus 3x. So for the ln 1 plus x, okay, so this is the expansion for the ln 1 plus x, like what we did just now. So let me copy first. Okay, please. Okay, okay, now the question asks for ln 1 plus 3x. So what you need to do, all x you need to change to 3x. So x, 3x minus 1 over 2 3x squared plus 1 over 3x cube plus, so 5 term, 1, 2, 3 minus 1 over 4 3x 4 plus 1 over 5 3x power of 5 plus blah blah blah. So your answer is 3x minus 9 over 2x squared plus 9 over x cubed. So 3 to the power of 4, we get 81. So 81 over 4 plus 3 to the power of 5. So by using your calculator, so 3 to the power of 3 to the power of 5, so you get 243. So 243 over 5x to the power of 5. So plus blah 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 x4. So this is the answer. 1, 2, 3, 4, 5 term. Okay, so this is the answer. Okay, for B, right, for B, so 3 ln, so I think this one should be square bracket 1 minus 2x squared 1 plus 3x. Okay, so when you expand, so you get 3 ln 1 minus 2x squared plus ln 1 plus 3x equal to 3 ln 1 minus 2x squared plus 3 ln 1 plus 3x. Okay, so here we get the answer from A. So now what you need to do, you need to get the expansion for this one first. Okay, so ln 1 minus 2x squared equal to so you need to change all x to negative 2x squared. So x is negative 2x squared minus 1 over 2. So here x squared, so x squared is negative 2x squared plus 1 over 3 negative 2x squared cube minus 1 over 4 negative 2x squared to the power of 4 plus 1 over 5 negative 2x squared power of 5. Then you expand, so the answer will be negative 2x squared. So 4, so 4 divided by 2, so negative 2x to the power of 4 minus 8 over 3x 6 minus 4x to the power of 8 minus 32 over 5x to the power of 10 plus blah blah blah. So this is the answer. And then you times with 3 d4 4. So 3 times and here equal to negative 6x squared negative 6x to the power of 4 minus 8x 6 minus 12x to the power of 8 minus 96 over 5x to the power of 10, and then plus for ln 1 plus 3x times with 3, so you get plus 9x minus 27 over 2x squared plus 27x cubed minus 243 over 4x 4 plus 729 over 5x 5 plus blah blah blah. Okay, so the question asks for the first 5 term. So first 5 term so equal to, so we get x, so 9x, so we get negative 6x squared negative 22 over x squared, so negative 6 negative 27 over 2, so negative 39 over 2x squared, and then x cubed, we have x cubed plus 27x cubed. Okay, so x4 negative 6 and x4 another x4 negative 243 over 4, so negative 267 over 4x4, and then to the power of 5, so okay, plus 729 over 5x to the power of 5 plus blah blah blah. So this is the answer. So the other ones, the power of 6, 8 and 10, so you just ignore that one because the question asks just for the first 5 term. Okay, so this is the answer for B. Okay, so question 5.15, I want you to do on your own, but I will give you the answer. Now the answer is okay, you have to try for this one. Okay, so 6x plus 6x squared plus 2x cubed minus 2x4 plus 16 over 5x to the power of 5 plus blah blah blah. Okay, since but the question asks for the first 4 term, so 1 2 3 4, so you just give until x to the power of 4. Okay, because the question asks for 4 term only. So this is the answer. Okay, And then for the next one, the expression for the trigo. So basically we want to get the expansion for sine and also for cos. Okay, let's do one for sine. Okay, expansion for sine. So sine x equal to a naught plus a1 x1 plus a2 x2 plus a3 x3 plus blah blah blah. Okay, and then you differentiate. So differentiate sine x, so we get cos x equal to a1 plus 2 a2x plus 3x squared. And then differentiate again, so we get negative sine x equal to 2a2 plus 6ax plus blah blah. Differentiate again, so we get negative cos x equal to 6a plus blah blah blah. Okay, so you stop. After you differentiate, and then you need to substitute the value of x equal to 0 into all this equation. So substitute x equal to 0 to the first equation. If let's say this is first equation, second equation, third and fourth equation. Okay, so you just substitute the value of x into this equation. So substitute x, so you will get a naught equal to 0, a1 will be equal to 1, a2 equal to 0, and a3 equal to negative 1 over 6. Okay, and then substitute back into the main equation. So this is the main equation. Okay, the first one. So sine x equal to x minus 1 over 6 x cube plus blah blah blah. Okay, but for this question, since we cannot get the pattern, if let's say lah, okay, I want to expand this one. Okay, I want to expand. I cannot expand because I cannot see the pattern. Okay, so what you need to do, you need to add. Okay, you need to add the other term instead of just x to the power of 3. So you add maybe 2 more term to this to the equation number 1, so that you can get the pattern of expansion for the sine x. Okay, so now for the equation number 1, so you expand a4 x4 plus a5 x5, so you differentiate, so you will get 4a4 x cubed plus 5a5 x to the power of 4. Differentiate, so we get 12 a4 x squared plus 20 a5 x cubed and then this one you get 24 a4x plus 60 a5 x squared blah. And then you differentiate again, so differentiate cos, we get negative signs, but because of negative, so we get sine x equal to 24 a4 plus 120 a5x plus blah blah blah. Differentiate again, so differentiate sign, we get cos x equal to 120 a5 plus blah blah blah. Okay, so you stop. So the same technique, substitute the value of x into the equation. So right now we have fifth equation, and so the equation number 6. So substitute the value of x into the equation number 5. So you still get a4 equal to 0, and then x equal to 0 into the equation number 6. So we get a5 equal to 1 over 120. Okay, so the expansion, so we extend the expansion. So now we get a4, so a4 is equal to 0, and also a5 is equal to 120. So plus so plus 120 x5. Okay, plus blah blah blah. And now we can get the pattern. So x minus 1 over 3 factorial plus, so 120 is equal to 5 factorial. So 1 over 5 factorial x to the power of 5. Okay, so we can get the pattern. If let's say I want to expand, I can expand because I can see that the pattern plus minus plus, this one will be minus 1 over 7 factorial x to the power of 7 plus 1 over 9 factorial x to the power of 9 plus blah blah blah. Okay, if let's say I want to expand, so I can expand. Okay, so this is the answer. So similar to cos, if I'm not mistaken, if you want to get the expansion for cos, you have to do cos x equal to a naught plus a1x plus a2x squared plus a3x cubed plus a4x4. You have to try, if I'm not mistaken, you have to extend until x to the power of 4 so that you can get the pattern for the cos x. Okay, so when you do this one by using the same technique like what we did just now, and you can get the expansion for cos like this. Okay, we try to do it. Okay, for the question example 5.16, so we have given cos something. Find the expansion for cos 2x and cos 3x. Hence, by using an appropriate trigonometric identity, find the first 4 term of the expansion of the following function. Okay, so we need to find what is the expansion for the cos 2x. Okay, so cos 2x, so all x you need to change to 2x. So 1 minus 2x squared over 2 plus 2x to the power of 4 over 4 factorial. 4 factorial is equal to 24 minus 2x power of 4 over 6 factorial is equal to 720. Yeah. And plus 2x power of 4 over 8 factorial is equal to 40,320. Okay, so please remember, it's not the only x you squared, but if this is 2x, so all x, so this x, so you change to 2x, so this one is x squared, so here it's become 2x squared, 2x, okay, to the power of 4. Okay, and similar to this one, 2x power of 4. Okay, it's not only x to the power of 4, but the 2 also you need to square. So equal to 1 minus 2x squared plus 2 over 3x4 minus 4 over 45 4 over 25, so 16 to power of 4, and then over 4, 320. So you get why this one power of 4? My mistake. This one is power of 6. 6. So power of 6. This one's power of 4. This one is power of 8. I'm sorry. So this one is 6. This one is 8. Okay, power of 8. Now you can get. So x power of 6. And then plus 2 over 315 x power of 8 plus blah blah blah. Okay, and then for the cos 3x, so you have to get this one. I want you to do it on your own, and you will this is the answer. 1 minus squared plus 27 over 8 x cubed minus 81 over 80 x cubed plus blah blah blah. Okay, so this is the answer. Okay, and then the question asks, hence by using an appropriate trigonometric identity, find the first 4 term of the expansion of the following function. Okay, so trigonometric identity, so refer to the list of formula. So refer to the list of formula. We have sine squared x that related to the cos 2x. So we have, okay, cos 2x is equal to 1 minus 2 sine squared x. So sine squared x is equal to 1 minus cos 2x over 2. 1 sine, so we move cos 2x and then move here 1 minus 2 over 2. Yep, so this is the answer. So to get the expansion for this one, therefore sine 2x is equal to 1 minus, okay, all this equation, okay, you need to substitute. Over 2. So final answer is 1 minus 1, 0. So you get x squared positive minus 1 over 3x to the power of 4. Minus is plus 2 over 45 x power of 6, and then minus 1 over 315 x power of 8 plus blah blah blah. Okay, so this is the answer. Okay, so this is the answer. And for the question number B, because of this one is the power of 3, actually we have the identity, trigonometric identity for cube. This is the expansion. Cos 3x equal to 4 cos cube x minus 3 cos x. So this is trigonometric identity for cube, but because of in our list of formula just until squared, so B you don't have to do lah. Okay. okay, because we just have in our list of formula until squared, so you don't have to do for b. Okay, right. Okay.